Okay, so today we're going to finish factoring. I'm going to work about, 8, 10 problems. And then the rest of the class period, I'm going to let you work on your worksheet. They are due tomorrow. Okay? So tell me what the last problem was that you have that we worked.
4x squared minus 25x.
Oh, okay. So y'all did example 7, right? Very good. Okay, so we won't have as many problems to work. We only have 1, 2, 3, 4, 5 problems to work. So that'll be good. You'll have more time in class. All right. So example 8. Now, I want to, while I'm working these 5 problems, I want to answer some questions and help you with some things that came up if you worked the first page of the worksheet like I asked you to. Okay? Even if you tried to work it and maybe you got hung up on some problems and stuff, I want to help you out with that. So we're going to be addressing some of those problems. All right? Does anybody have a question?
About the worksheet last night?
No?
I don't know.
Okay. So here we go. The first problem. Negative 5x squared plus 45. Okay, so when you're factoring, what is the first question that you should ask yourself?
Can I take anything out?
Can I take anything out? Okay, what can you take out? 5. Okay, y'all listen to me. I'm going to tell you something. I'm never, ever going to factor a negative x squared. Okay? Can you? Yes. But it makes all the rules.
Excuse me, teachers, please pardon the announcement. I know many of you have been asking for updates on the internet situation, and we can't send out an email to update you because the internet is out. So I had to interrupt your class. I apologize. Basically, we have one update from Region 5, and that was at about 8 o'clock this morning, and they said it would be repaired in a couple of hours. As you can tell, that did not work out. So we have no further updates for you except for the fact that it's not repaired, if you're curious. So continue to please submit your attendance as best you can via Skyward or paper, and hopefully it'll be repaired by tomorrow. Go Battle Bears.
All right. So here's the deal. Whenever you have a negative on the x squared, when you try and factor it, it makes all the things that you were taught, it messes them all up. And then you're like going, what? No, wait. Okay? So anytime there's a negative on an x squared, I'm going to take that negative out. Okay? And it's going to change the sign of everything that's left. Everything that's in there, it's going to change its sign. So instead of just taking out a 5 here, what am I going to take out? A negative 5. This negative is going to change all these signs. So it's going to make this guy positive and this guy negative. Okay? What do you multiply negative 5 by to get negative 5x squared?
What? I don't know.
What do you multiply negative 5 by to get negative 5x squared? X squared. What do you multiply negative 5 by to get positive 45? Negative 9. A negative times a negative is a positive. Okay? Now, ding, 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 ding. Every bell and whistle in your head ought to be going off, right? Because what is this guy? What is this guy?
A binomial.
What?
A conjugate.
Oh, come on, people. Difference of 2 perfect squares. People, y'all better step it up. Step it up. Okay? Difference of 2 perfect squares. Well, you hadn't been here for 2 days. They have. All right? And what does it factor into? X plus 3 and x minus 3. And there's my answer. Okay? Now, if you did not take the negative out, one of you will either have negative x minus 3 times x minus 3, or you'll have x plus 3 times negative x plus 3. All right? It'll be weird, but you can do that. You can do that. All right, so here's example 9. I'm just saying it's a whole lot easier if you just factor the negative out, and then you can factor it and follow all the rules. Okay, so let's look at this one. 8t squared plus 38t minus 10. All right, what's the first thing we're supposed to ask ourselves? Okay, can I take anything out? Yes. Okay, so this is what I saw kids doing. Even on this problem up here, they were just dividing everything by 5 and then just writing negative x squared plus 45 or x squared minus 9, okay? And then they were dropping this term off. So listen to me. When you get this answer down here, if when you multiply this whole answer out, you don't get the problem, you're wrong. We're not dividing things out. You're factoring things out. Is factoring something out the same as dividing it? Well, it is, but you got to write it down. You can't just like make it go away. All right? So if you had this problem here and you left off this front factor, you missed half the points. Okay? There was a whole bunch on the worksheet and I saw kids dividing them by 2 or whatever. And I'm like, really, we're not dividing here. You can't divide because you don't have an equal sign. It's not like you can do to one side like you do to the other side. There's only one side. Okay? So we're factoring. So is there anything that I can factor out? A 2. Okay? So what do you multiply 2 by to get 8t squared?
4t squared.
What do you multiply 2 by to get 38t?
19.
19. What do you multiply 2 by to get negative 10?
5.
Negative 5. Okay? Now I'm going to try and factor this guy right here. Okay? Here's where I'm going to get my pencil out, right? That's what we talked about yesterday. I don't have a pencil. Oh, here it is. Okay, so the factors of 4 are 1 and 4 and 2 and 2. The factors of 5 are 1 and 5. Okay, generally, I'm going to lean toward this 2 and this 2. Do you agree? In this case, am I going to, huh?
No, you're going to do 1 and 4.
Right, that's what we're going to talk about right now. Okay, so someone said, no, we're not going to the 2 and the 2, we're going to the 1 and the 4. Why in this case would you go to the 1 and the 4
Because
first?
4 times 5 is 20, and that's close to 19.
Very good. So when you multiply the first and the last numbers in this trinomial, if this number in the middle is really close to that number, or it's close to 1, then that's said to be an extreme. And that means you want to use the extreme numbers. So, now I'm going to start with 1 and 4. Y'all listen to me. Does that mean, because that's a 19, that the 1 and the 4 are going to work? No, it just means that's a good place for me to start. Okay? So I'm going to start with the 1 and the 4. Now remember yesterday I told you how I did it in my head. Okay? So I'm going to show you again how I did it in my head. What I'm going to multiply. I'm going to pretend like the 2 and the 2 are not there. I'm going to multiply. I'm going to go straight across. Multiply here and here. What will I do with those numbers? Add them or subtract them?
Add
No. Subtract.
This guy's my cheater sign. He tells you what. No.
Subtract.
Subtract. This last sign tells you what to do with those numbers. Okay? So let's try it. You go across first. If that doesn't work, then you go on the diagonals. Okay? So what's 1 times 1?
1.
What's 4 times 5?
20.
Do those subtract to be 19?
Yes.
1 and 20 subtract to be 19. Okay, so here's what I'm going to do. I'm going to show you a way. Y'all look, here's what happened. The first year when I taught kids, because kids were like, how do you do it, Miss Davis? You write this little stuff up there and then you like do it in your head and you know the answer. And so I told them how to do it, but then they couldn't figure out how to take what they knew and put it down here. Okay, so this is what I've come up with showing them. I want the 1 and the 1 to go together, so I'm going to put a box around both of those. I want the 4 and the 5 to go together, so I'm going to circle both of those. I'm matching them up, okay? So I'm using 1 and 4. I always put the big number first, but that doesn't really matter. So 4t and t. I'm not going to put the signs there. I'm going to show you how to do it and put your signs later, okay? Now, the 1 goes with the 1 and the 4 goes with the 5. If I want the 4 to go with the 5, where does the 5 have to go? Yeah, on the outside. So they're your outers. Okay? And the 1 goes with the 1. They're your inners. That's my 1t. Okay? So the 1 here. Now I want a positive 19. So where does the plus sign go?
With the 5.
Yeah, the 4 and the 5, because that's my 20. All right, so I'll make a plus here and a minus here. Now, if you don't get that, then just put them somewhere and then check. Because even though I put them where I think they belong, I still check. My inners are negative 1t, and my outers are positive 20t. And that is my positive 19t. Anybody got a question? Okay, so now this is like the front page of the paper. Okay, the back page of the paper says, it doesn't say to factor, it says to solve. Oh, let me show you one other little thing too. We talked about this in the last class. What if you just got really busy and you were stressed and trying to hurry and you factored whatever it was you were factoring and you ended up with these as your factors? Tell me what you see there that should have happened.
You take out 2.
Yeah. Anytime you see a factor that something can pull out, then you could just say to yourself, dang, I should have pulled a 2 out in the beginning, and that would have made it a lot easier to factor. But I can still pull it out right here. Pull it out front. What are you left with right here? X minus 3. This and this are the same thing. Okay? Now, what if it looks like this? What if someone had factored it and they got x plus 7 times 2x minus 6? Still looking at this guy going, what? 2 and 6? I should have pulled a 2 out. I'm still going to pull the 2 out. Nope.
At the end.
I'm just going to put it at the beginning.
Oh.
Because does the order that you multiply things in affect the answer? No. So I don't care what order they're in. That doesn't make any difference. This is this, multiplied by this, multiplied by this. But generally, your constants, your coefficients like this, they go out front. Okay? Anybody got a question? Just
Does that
something to
even
look
matter
for.
that the other one didn't have anything to take out?
Nope, doesn't matter. Because you're not distributing it. It's not like 2 multiplied by this and 2 multiplied by that. It's just 2 times that. Okay? Now, this is what I'm telling you. If you see a factor and you didn't take something out, if you left your answer like this, I would give you half credit for it. Because it's not fully factored. Okay? It's fully factored. Okay? Don't throw these 2's away. You know how up here, like right here, a lot of kids just divided by 2 and they got this answer right here, and then that's their answer. That's half credit, people. You have to have that too. So if you did that on some of your problems, you need to go find that whatever it was you divided by and pull it out here. Okay, the back half of the paper is a little bit different because it says solve. All right? So we're going to do 3 problems and then we'll be finished. So example 10. Okay, example 10. 3x squared plus 10x minus 8 equals 0. Still going to do the same thing that we have been doing, all right? We're going to ask ourselves those questions because the way to solve a quadratic is to set it equal to 0 and factor it, okay? So, can I take anything out? No. 3 and 10? No. Everybody doesn't have an x? No. Can't take anything out. Is it special? No. I mean, 3's not a perfect square, minus sign, 8's not a perfect, I mean, he's all over the place, not special. All right? So now we're going to just factor in like this. Okay? I'm going to list my factors up here. 1 and 3. 1 and 8, and 2 and 4. 3 and nothing, and 4 and 2. Okay? Do you like it when I do it in my head? Yes or no? Not really? Okay, so I'm not going to do this one in my head. If you want to do it in your head, you can, but if you don't like it, people, you can just guess and check. All right? So 1 and 3. So I'm going to say 3x and x. What does a minus sign at the end mean? Yeah. So one's a plus and one's a minus.
Can you withhold from putting, like, not like right now, but like in general, you don't
Yes,
have to
you
always
can.
put them?
That's right. Some kids don't like to put them until the end, and then they put them in the right place.
Okay.
I just put them and then I erase them if I need to. Okay? So I have a choice here. Could I use a trick and maybe make a wiser choice?
Yes.
Am I gonna use 1 and 8 or 2? Am I gonna try first 1 and 8 or 2 and 4? Yes. This number is not extreme. 3 times 8 is 24. No, he's not close to 1 and he's not close to 24. So that means I'm not gonna use these extreme numbers. I'm gonna use these ones that are closer to each other. Okay? So I'm gonna try 2 and 4. We'll just plug them in. 2 and 4. So I get a plus 2x, a minus 12x. So I got a negative 10x. The number's good, the sign's wrong. What gets moved? Yeah, just change your signs. This becomes a plus, and this becomes a minus. Okay, I'm not finished because they asked me to solve it. So I want my solutions right here. Okay? Now, if x plus 4 is the factor, what's the solution? Negative 4. Remember how we changed his sign? Y'all remember that? That was the first day you came back to school, Tuesday. Okay? Now, what about this guy right here? Anybody know what that one's going to end up being?
2/3.
Fraction?
Yep.
Positive 2/3.
2/3. Positive 2/3. Okay? So let's say that you're like, what? Where are they getting that? Well, how did you get negative 4? Well, you said x plus 4 equals 0, and you subtracted 4 from both sides, and there's your negative 4. So you can do the same thing over here. 3x minus 2 equals 0. You're going to add 2 to both sides. Divide by 3. And there's my answer. So here's what you're doing essentially. You're changing this guy's sign, and you divide by this coefficient. You change this guy's sign, just like you changed this guy's sign, but his coefficient is 1, so I don't have to divide by it. But this one's not, so you have to divide by 3. All right, now if I graph this right here, like if this said equals to y, and I graphed it, what would it look like?
A U.
A U, a parabola, right? Okay, where is it going to cross the x-axis?
At 2/3 and negative 4.
Very good. 1, 2, 3, 4. Negative 4 and 2/3. Okay, is it going to open up or down? Up. My x squared is a positive x squared. Is he going to be wider, narrower, or the same as the parent function? Narrower, because 3 is bigger than 1. Remember, if it's between 0 and 1, that makes it wider. Okay? So he's going to look something like this. Do you agree? To be wide like a 3 is probably going to go down kind of far. We could find the vertex. Remember how to do it? You add these two things together and divide by 2. That gives you the x coordinate or the h. You plug it back in and find your k. All right, here we go. The next one, example 11. 5p squared minus 16p plus 15 equals 4p minus 5. Wow. What are we going to do with this guy?
Combine those terms.
Combine my terms, because we have to make it equal to what? 0. Okay? So I'm going to subtract 4p from both sides, and I'm going to add 5 to both sides. That will give me a 0 over here on the right. On the left, I get 5p squared. What's negative 4p and negative 16p?
Negative 20.
Very good. And what's 15 and 5? Positive 20. Okay? So what am I going to do? Take a 5 out. Can I just divide it out and pretend like it goes away? No. Okay? No, you can't. And here's why. Because if you make this 5 go away, will that parabola, if I were graphing it, would that parabola look just like this parabola? If this 5 wasn't here? No. This one's going to be very steep, and this one wouldn't. He'd be normal. So you can't just throw him away. All right? So you're left with a p squared minus what? 4p plus what? 4. Okay? Oh, look at that guy right there. What is he? Yeah, he's a perfect square trinomial. See? This is the perfect square of p, and this is the perfect square of 2, and that middle guy is twice their product. So he factors into p minus 2 quantity squared. Are you with me? This is a lot, okay? Now what do I wanna solve it, okay? I need to get rid of that 5. Can I distribute that 5?
Nope.
No. You have to raise to a power first, then you'd be back up here, okay? So how am I gonna get rid of that 5?
Divide it out.
Yeah, I'm just gonna divide him out. Now watch, y'all, it's gonna look like he disappeared, but he didn't really. We did not just chunk him away. What's 0 divided by 5? Now, you see how it looks like we just threw him away? Because 0 divided by anything is gonna be 0. It's gonna look like you threw him away, but you did not. Okay? So here's my question. What's my answers?
Not possible.
Do you do that little trick we did with 3?
Wait, is it gonna have the same solution? All real numbers.
No.
My bad.
What? Okay, so do you agree that this right here means this? P minus 2 times P minus 2. Do you agree with that? So it's 2 and 2. Okay? Do I need to write it twice?
No.
No. It's kind of redundant. Alright, so I'm going to write a 2 down. Now, here's the problem. Okay? Y'all, a long, long time ago, there was a famous mathematician. His name was Carl Friedrich Gauss. Okay? I call him Freddie. Alright? And Freddie discovered the fundamental theorem of algebra. Okay? And here's what the fundamental theorem of algebra says. Oh, Freddie was studying up and he said, wow, look at this. He said, whatever the highest exponent is in your equation or your polynomial, that's how many answers you get. So on quadratics, that's why they have 2 answers. Okay? Does this guy have 2 answers?
Yes.
Yes, he does. 2 and 2. They're just both the same thing. So do you see how that looks deceptive?
Yeah.
Because it's only 1. So here's what we do. We put dr beside it. Okay? dr. dr stands for double root. So it does have 2 answers. It's just the same number. Okay? So the dr is saying, hey man, I know there's 2 of them. It's okay. Okay? I know Freddie said we got to get 2 answers. I got my 2 answers. Now here's my question. Here's another question. How can a parabola only touch the x-axis in one place? At 2. That's its vertex. Okay? He opens up because this is positive. All right? He's very skinny. But that is my vertex. So this is what he looks like.
So it's like if you bend the ends of the piece of paper and it just sits there?
That's exactly right. And it just sits there.
Okay.
Okay? Look at what else. Man, look at what else I'm showing you. Can you replace a 0 with a y? Is that legal?
Yeah.
Yeah, it is. I can replace a 0 with a y. So you mean I can graph this equation on my calculator and check my answers? Huh, that's pretty cool. That's why we're not using calculators on the test. Okay? But you could use them on your worksheets if you wanted to. All right, one last problem and then I'm gonna let you work on your worksheet. Here's what it looks like. It's gonna be a weirdo. 3x to the third plus 20x squared minus 7x equals 0. I'm solving it, okay? I'm solving it. Hey, if Freddie were here, he's not because he died a long, long time ago. But if Freddie were here, how many answers would he say this guy had? 3 answers, okay? 3 answers. All right, so let's solve it. Tell me what to do first. Take out an x. Very good. Can you factor something out? Y'all look, if all of these were multiplied by 2, I would take out a 2x. Do you see what I'm saying? Okay, so I'm going to take out an x. What do you multiply x by to get 3x to the third?
3x.
What do you multiply an x by to get 20x squared? 20x. You're just taking one of the x's away from everybody. What do you multiply x by to get negative 7x? Okay? So now, obviously, we're going to try to factor. Don't throw this factor away, guys. You keep anytime you factor something out, you keep bringing it down. Okay? So, the factors of 3 are 1 and 3. The factors of 7 are 1 and 7. Okay? 1 and 21. 1 and 21. Do they subtract to be 20? Okay, so that's what I want. That means I want my 1 to go with my 1 and my 3 to go with my 7. So I'm going to go 3x and x. 3 goes with 7, so 7 needs to be outside. 1 goes with 1, so my 1s have to be inside. Now what kind of 20x do I want? A positive. So where's the plus sign need to be? Yeah, on the right with my 7. And my minus signs have to go here. Okay? So let's look at my answers. My solutions, my roots, my zeros, my x-intercepts. What is this one? -7. Okay? Let's see how good your memory is. What about this guy?
-1/3.
Change the sign.
No, 1/3.
There you go. Positive 1/3. Very good. What about this guy out here?
Just bring it down.
Isn't it 0?
It is 0. Okay? Think about this, y'all. How did you get this -7? You said x plus 7 equals 0, and you subtracted 7 from both sides and got x to be -7. How did you get 1/3? 3x minus 1 equals 0, so you added 1 and divided by 3, got 1/3. Look at this one. X equals 0, bam! You don't even have to do anything. The answer's staring at me. And there's my 3 solutions. Okay? Anybody got a question?
Do we still say double root?
Nope, because he only occurred one time. Now listen to me. If this had been 3x to the 4th, 2x to the 3rd, and 7x squared, and I had taken an x squared out, then that 0 would have been a double root. He would have occurred x times x, and that would have been 2 times. Okay? Because he would have had 4 points, because it was 3x to the 4th, right? Okay, so I want you to be working on your worksheet. Okay, if you have some questions, I'll be more than happy to help you. It is